Hi, this is Elliot Fishman, and welcome to Facebook Live. Trying to move over, get centered here in my office. Those of you who don't know better, let's see if I can point correctly. See right there? That's a Next computer. That was the computer that Steve Jobs built after he left Apple. And that died eventually, but Next was bought out by Apple, and the Apple operating system you use today was the operating system that was developed for Next. So all's well that ends well, but I still have those computers. Believe it or not, Bill Brody was chair, so that was in the early 90s, 30 years ago. They were $25,000. Think about that for a second. Talk about your expensive PCs. Anyway, AI of the pancreas. I just wanted to, when Lily was asking me what topic to talk about, I couldn't quite think of a specific topic, but I thought about that one in the sense that we're doing a lot of work with it. And I just wanted to bring you up to date. There's so much going on with AI now in the pancreas. People are looking at things from early detection. Remember radiomics from Mayo Clinic a few months back, picking up tumors 2 or 3 years before radiologists could see them. People are looking, and we are, for early detection of pancreatic cancer. Not so much in the screening patients, and we're worrying about high-risk patients, but in every scan that you get to look and see, can I see something? Things like that would be very, very important. We also looking at AI for distinguishing tumors, cystic lesions that need to be resected versus those that can be followed, those that are worrisome versus those that you don't need to worry about. We're working very, very hard on looking at predictability. Can you predict who needs surgery? Can you predict who needs chemotherapy? And if you need chemotherapy, pre or post surgery, can you predict who will do well with chemotherapy, who will not do well with chemotherapy? There's so many decisions that need to be made where there's not really great data. The question is, can we use AI to be more predictive? That is really where the excitement is. We're also using the whole idea of AI in the pancreas is that really the range, as I mentioned, from detection to staging to management to outcomes, selecting the chemotherapy, selecting the radiation therapy. When should surgery be done? Why do some people do well? Why do some people not do well? The ability of AI not just to look at imaging, but to look at imaging plus lab results, all the new biomarkers that are being developed, things that we look at the additional blood work, we look at some of the information in the tumor and the tumor subtypes, all of those things. Can we use that to be more predictive? What we're trying to say is there's so much information now that we really don't use or we don't know how to use. The question is, how can we use that information better? What is it that we can do that will make things better? That's really where we're trying to focus now. Yes, we need more information, okay? We need to make the scanners better, the scans being able to detect smaller things. But there's so much information already that we have. I think our issue is not being able to use the information or to be able to use the information correctly. That is really where we're trying to do things. The ability for us to be able to truly impact the lives of our patients, to impact on what we're doing. If you go to the CTisus website, you look at the articles on AI and pancreas, you'll see them. You'll see a lot of the things, a number of articles by Linda Chu, Satomi Kawamoto. We're doing lots of work with Lustgarten Foundation, who is supporting us. We're doing work with Microsoft, who's supporting us and working closely with us, their AI group. So I think one of the things also in AI of the pancreas, the importance of a team approach. Truth is, medicine these days to be successful is a team approach. But the ability to use radiologists, pathologists like Ralph Rubin, surgeons, Chris Wolfgang, Jin He, oncologists, think about someone named like Dan Leheru, GI folks like Anne-Marie Lennon, getting all of these people together and then working with the world's best computer scientists, the people developing the next generation of computer algorithms, whether it's things like ChatGPT or GBM, which is basically transparent AI instead of this opaque black box, which everyone has a problem with, transparent. We can look at why we predict what we predict and perhaps then make things better. This ability to take all the information and clarify the information is something that I think is very important to all of us. So to me, we're at the beginning of this journey. We need to somehow figure out how to make the journey go fast. Not that we're in a rush, but we are in a rush because patients are dying. 60,000 plus patients are dying from pancreatic cancer every year. We need to improve detection. We need to improve management. We need to improve outcomes. And I think AI can check each of those boxes. So we'll come back with you with articles, with cases, with information. I think it's something that needs to happen, is happening, and we're excited to be part of it. And I think all of you out there, we'd love to hear from you, but tell us what you think. Whether it's on pancreas or kidney or liver or stroke or whatever you're doing, how are you using AI? Where do you see it's going? And what do you want and what do you expect? And with that, I wish everybody a great Thursday and a great weekend. Next week is July 4th. I also, again, final goodbyes to our fellows, the residents, first hello to our new fellows and residents, and we look forward to an exciting 22-23, no, we're in 23 already, 23-24 academic year. Have a great day, everybody.